I just forgot to mention something. Have a look at the water depth. Okay, you can see Gulf of Carpentaria slightly above 50 meters. Okay, there's a channel, Arafura channel, but overall 50 meters, 100 meters is relatively shallow. By the way, the shelf all around Australia is only about 100 meters deep, but this region here is also close to the equator. Okay, so let's define what we call shallow water. Away from the equator, you typically have the situation where the surface and the bottom Ekman layers are separated from each other. This is what we can call deep water. In this situation, you have typical wind-driven coastal upwelling, with offshore and onshore movements in these Ekman. In between is a geostrophic layer, pressure gradient driven. So now how we can define shallow waters? Shallow waters are the zones where you have an overlap of both regions. So the water depth is less than the combined thickness of the Ekman layer. You get an interaction or an interference between the surface and. So you can define shallow water as the regions where this ratio between total water depth and the sum of the Ekman layers thicknesses is less than 1. Okay? And this is a dynamical definition. And what it means is if you're in shallow water, then the effects partially or completely cancel out effects of both Ekman. And you already heard before that the flow deflection that you get in the surface and bottom Ekman layers, they're essentially opposite to each other. Okay? So that sort of you get an idea of how this cancellation actually works. Okay, so this is the starting point.